Hello everybody, this is Rudra Pradhan here. Welcome to BMD lecture series, and today we will continue with prescriptive analytics and that too coverage on sensitivity analysis. In fact, in the last lectures we have highlighted some of the issues with respect to sensitivity analysis. So, now we will continue with this similar kind of discussion, and then we will address more effectively this particular component, that too the sensitivity analysis in the LPP structure, that is the linear programming problem structure. So, in the last lectures we have already highlighted the particular requirement and the utility of this sensitivity analysis, because the business is very dynamic. Any point there may be possible change, that too because of the business requirement, the kind of change of the business environment and the volatility of business, and the with respect to competitions, and with respect to some kind of control mechanisms, or some kind of external factors. So, that means there is in reality there is a kind of possibility that the particular problem can change, that too with respect to the coefficients of the objective function, the coefficients of the constants, and the kind of conditions. So, now with a given situations we look for the optimality, again we look for the optimality with the changing situation. This is the overall kind of structure of the sensitivity analysis. And in fact, in the last lectures we have already highlighted the particular objectives of the sensitivity analysis, or this particular unity objectives. And to continue on that particular component, so what I like to address, so the sensitivity analysis will give you the kind of clue where the decision maker can determine how to change or how to bring a change in one of the values of the model, and that will impact on the optimum solution and the optimum values of the objective function, while holding all other parameters constant, and provides that decision maker with greater insight about the sensitivity of the optimum solution to changes in various parameters of a problem. Then again we quickly look for the kind of improvement with respect to the particular change scenario. So, that means technically it is a kind of continuous process or iterative process. So, every times we can jump to a particular step or the kind of positions where we may have a kind of improved situation, that too with respect to values of the decision variable and the values of the kind of objective functions. So, whether it is a kind of original structures where we will do the iterations and then look for the optimum solution, and again after reaching the optimum solutions, again the iterative process will continue if there is any change with respect to objective functions, with respect to constants, and the kind of conditions. So, that means technically, so it is the kind of continuous process or iterative process till we get the optimum solution as per the particular requirement. So, that means this particular structure will give you enough flexibility. So, this is what the original kind of requirement. And now, if the business will change like this, then the particular solution will be like this, So, that means we have a kind of flexible kind of structure through which we can actually come to a kind of solution for a business problems, and then the management decision will be very effective as per the particular business requirement. So, now so the first answer structure is a change in parameters value, and that too. So, the value of the objective functions and the right hand side of the constants and left hand side of the constant, and the coefficient of a particular constant. So, now the issue about the changes are which range we can change the particular structures. Of course, in a kind of predictive kind of environment, for instance with a given models with respect to objective function, constant, and conditions, we look for the optimum solution. Now, in the kind of future requirement, we we may not have any idea about to the kind of business environment or the kind of business problem, but any change which you like to apply. So, there should be some kind of plan or some kind of logic through which you can actually change the kind of requirement, and then we look for the optimality or optimum solution with respect to every change situation. For instance, let us say with a particular situation. So, our objective function is with respect to x 1 and x 2, that too the coefficient of objective function for x 1 is 60 or and 50 for x 2. So, then you allow the particular coefficient to change with a 10% increase, 20% increase, 30% increase, keeping other things remain constant, then you look for the optimum solution. Again, in the research sites, it may be changed with respect to availability. Let us say today the labor hour is, let us say availability is 100 hours. So, with respect to future requirement, the 100 hours may increase with 10%, 20%, 30%. That means, we must have a planning, proper planning, through which actually you first fix the possible changes, and then for every change situation, that is with respect to problem structuring, then we look for the optimum solution, or we search for the optimum solutions. That is how the kind of beauty of this sensitivity analysis. And again, so far as the range of optimality is concerned, finding the range of objective function values for which the optimum values of the decision variable would not change, and again a value of the objective function that falls within the range of optimality will not change the optimum solution, though the optimum value of the objective function will change. So, that means, we have a kind of flexibility altogether, and so far as the feasibility is concerned, the range of values over which the right hand side value can change without causing the kind of shadow price to change. Then within this range of feasibility, the same decision variable will remain optimal, although their values and the optimum value of the objective function will change. And analysis of right hand side coefficient changes with determinants of constant shadow price in the optimum solution. So, that means, when we change the particular structure of the problem, so there is a high chance that the optimum solution will change, but there is in the same times there is a high chance that optimum solution will not change at all. For instance, suppose we are using a particular constant with a it is a kind of production process, and we are allocating resources effectively, but keeping other things remain constant. If you increase one after another unit of resources for a particular constant, then I am very sure after a particular point of time the value of the objective function or the optimum solution, that is the values of the decision variable, will not change if you continuously increase the coefficient of that particular constant, keeping other things remain constant. So, that means, it is not that every time change of the constants or the change of coefficients will change drastically the optimum solution. It depends upon the type of problem, the kind of business, and the kind of requirement, and obviously there is a possibility of change, but not necessarily that the change will happen with respect to change of all the structure of the problem. Again, to address this sensitivity structure, the same problems we can highlight, which we have already solved in the case of graphical method, simplex method, and again we solve through solver package. And then this is what the original solution corresponding to this problem, that is with respect to two variables x 1 and x 2 with the three constants, and the objective function is maximization type, and the constants are less than type, and as a result, so we have the typical structure like this, and this is what the feasible regions, and then we are looking for the kind of solutions. Now, coming to the sensitivity structures, you see here. So, the first structure of the kind of sensitivity. So, this is the original objective functions, and this is what the first objective function. Now, any change of the particular coefficient of the objective function, then the position of the objective function will not remain same. So, it will change. So, the movement will be go like this, and again any other change of the coefficients, again it will move like this. So, that means keeping other things remain constant, if you change the coefficient of the objective function, if the coefficients of objective function will be at the increasing rate, then obviously the value of the objective function will be also at a increasing rate. If it is actually less than to original situation, then the value of the objective function may be less as per the original situation. Obviously, we have no clear idea of what will be the final change with respect to change of these coefficients. So, now again we have to go in the kind of iterative process and follow the kind of procedure, then ultimately we look for the kind of final solution, whether there is a change or it is still as per the particular requirement. So, now the optimum values which we have already solved is x 1 equal to 9, x 2 equal to 4 and z equal to 740. And now, with respect to kind of sensitivity analysis, let us say the coefficients of objective function will be changed to, instead of 50 it will be changed to 100, or instead of 30 for x 2 it will change to 60, then what should be the possible optimum solution. So, accordingly you have to actually again look for the final structure, and then we can actually, that means if you are changing the coefficients of the objective function, then the constants position will be remain same, and the same corner points and the kind of values of the decision variable. Just what will it do? So, put the values of the decision variable with respect to original means new objective functions, where the coefficients of that objective function is changed now, and then we see whether there is a change of optimum solutions. So, this is again kind of dynamics of this particular requirement or the kind of business. And again, so this is another kind of situation, if you change, then what should be the kind of possible solution. So, now here there is a kind of structuring, like we have already discussed in the inferential analytics and the kind of predictive analytics, with a kind of problem and the kind of ability of data and the kind of structuring. So, we may have some kind of solutions, the values of the decision variables. Now, here since it is a kind of optimization problem, so we are looking for the values of the decision variable, but in the case of inferential analytics or predictive analytics, the similar kind of structures, where we are looking for a kind of objective orientations. For instance, in the case of inferential analytics, we have solved couple of problems to find out values of the population parameter, and then we are looking for the confidence interval for these population parameters. Now, here also same thing. So, we are looking for the values of the decision variable, and that with the condition that on the values of the decision variables are in a kind of positive shape only. So, now here we can also create a confidence interval. So, for instance, we can put the restriction about the x 1 or x 2, and then let us say x 1 may be with respect to 20 and 30 range, or x 2 equal to 40 and 50 range. Then again rerun the models and check whether there is a kind of optimal solution or not. So, that means it is a kind of again flexible kind of scenario. And of course, when you add one after another constant, then your feasible zone will be restricted, and then solution will be very pointed kind of things. And means we are searching the kind of the kind of requirement only. So, obviously, if you focus the problem perfectly, obviously the solution will be also as per the particular requirement. So, that means with respect to the kind of change, so we will have a kind of change scenario, and again look for the kind of optimality. So, here also, like in the case of inferential analytics and predictive analytics, we can have here also confidence interval for the values of the decision variables, and then look for the optimality, where we can have the optimum values of the decision variable and then the value of the objective functions. So, now these are all possible change agents, and this is what the structuring, and the same structure. So, when we change the particular structure, then the upper bound will be a having 43.5 and the lower bound is 33. So, that means, if you change the kind of structuring, then the since it is a linear combination of x 1s and x 2, obviously we like to know what is the contribution of profit from the product 1s, that is the x 1s, and what is the contribution of product 2, that is x 2, and then what should be the final profit in that is the combined profit for both x 1 and x 2. So, it depends upon the kind of the contribution of the objective function coefficient and the kind of values of the decision variable. So, now this is against the kind of flexibility, and with respect to lower limit and upper limit. Again, if you go to the kind of solver package where we have already solved some of the problems. For instance, if you go to the kind of solver package, you will find here. So, this is what the solver package we have already discussed. Now, what will you do in the kind of sensitivity analysis? Let us say the original problem is with respect to 60 and 50. So, now you change actually, let us say we increase to 70 say. So, now instead of 60 you put 70 here, and in this case you put let us say 60, and then what should be the kind of possible change. So, again you go to the solver, and then the model is already actually finalized. So, either you can reset the process here, there is option for reset all, then you can do that, and after that again you put the solve options and then look for the solution, it will automatically change the particular. So, earlier it was a 740, so now it is coming 870. So, now again similar kind of structure, the first constant is non binding, and then the second constant, third constant is binding. Again, if you add one more constant, then again you have to go to the solver, and in this case in the previous change situation, we are just changing the coefficient of the objective function as a result. So, there is no structural change here, but if you add one constant here, then obviously in the input box here. So, you have to put add on here. So, provided you must have information here, and then accordingly we look for the solution. For instance, let us close here. So, you can put here let us say one more constant here 1 and 1, and then put the limit here let us say 20, and then check whether the solution is coming or not. So, in this context again you go to the kind of again you allow that this will be also less than type, and what will you do? So, you go to the solvers again, and here there are only 3 constants, and then you have to put add on, that is the third constants, that will be here, and again. So, the signal is less than type, and the constant limit is actually here 20, and then again you put OK. And so, as a result the third constant is added into the process, and then again look for the optimum solutions, and then OK. So, this is what the solution is all about. So, it is again coming 870, and it is again actually satisfying the kind of criteria. So, ultimately so this is a kind of situation through which actually we will look for the optimality, where the optimum solution structure is changing as per the particular change requirement. So, now corresponding to these problems, so here's so the issue is how quickly you can address these problems, and then look for the change situations, and then look for the optimal solution with respect to the change scenario. So, now means in these problems what we have already discussed here, and these are all optimum solutions, and that too with respect to changing situation. All right. So, now what is happening here? So, if you go to the actually Excel sheet here, so this is what actually the answer report, and you find here this is what the original solution 740, and without any application of sensitivity analysis. And in fact, what we have already discussed here, the first constant is not binding, and the second constant is showing binding, and third constant is binding. And so far as the sensitivity report is concerned, we have here sensitivity report, and the objective coefficients are 60 and 50. And if you allow increase 40 and 10 and allow decrease 10 and 20, then what should be the possible optimum solutions. So, these are all various possible solutions, and with respect to this particular problems, right. So, that means technically what I like to say that a sensitivity analysis has actually beautiful kind of structure through which it will give you or it will bring some kind of multiple options through which you can address the business problem more effectively, and then we come with a kind of management decision as per the particular requirement. And in fact, in the predictive analytics structures, we call this particular component, or we call this particular structure called as robustness. We have a different kind of flexible structure through which you can pick up the best as per the problem requirement and the management requirement. Here the similar kind of structure, but here the particular structure is called as sensitivity structure, that to what should be the optimal solution corresponding to change of the scenario, that to with respect to the coefficients of the objective function, the coefficients of the constants, and the kind of conditions. So, these are all various optional change, and that too we look for the optimum solutions. And so, we like to address here some of the cases like this. So, that means technically what we have already discussed in the kind of sensitivity analysis. So, that means we have highlighted the problems, and that to look for the optimum solution with respect to objective functions and the kind of constants. So, then we allow the kind of problem with respect to change scenario, and that should be actually in a kind of logical setup, or the kind of the future requirement, or the kind of management requirement with respect to management objectives. So, that means we like to first predict the possible changes that to apply in the case of objective functions with respect to constants and the conditions. Then for every change we look for the optimum solutions. So, that means whatever changes you will bring. So, for every change we will find another kind of optimum solutions. Now, we must have a kind of comparative analysis, that to we have original optimum solutions. Now, with respect to any change of the particular problem structure, what should be the new optimal solutions. Then we can compare with the original optimum solution with the new optimal solutions. Then we freeze accordingly as per the particular requirement. So, that means with a given situation we have optimal solution corresponding to objective function and constant, and then we will have a here kind of prospective solution for the future requirement, provided we must have a kind of predictive kind of structure that with respect to objective function, constant, and the conditions. So, that requires enough exposure to understand the problem, understand the business environment, and then look for the solutions as per the particular management requirement. And what I have already mentioned. So, when we will apply sensitivity analysis, so there are number of possible changes can happen, and that too with respect to coefficients of the objective functions, coefficients of the constant, that to left hand side, right hand side, and you may have the option to add one after another variables. We can have options to add one after another constants, and any change you will apply, then again you rerun the model and look for the optimal solution. And the beauty of this system is here. So, once you get the optimal solutions, so now any change you will apply, that too. So, the change will be effective at the final optimal solution only. So, that means in the simplex procedure, so your final optimal tables will be the input for any change scenario. So, any specific change with respect to a particular options, that with respect to objective function or with respect to constraints or condition, then we look for the optimum solutions, and then we like to address the problems, how is the kind of change scenario with respect to original structures. So, so if you sum up, then there is two possibility. So, the first possibility is there is no change of optimum solution corresponding to the change situation, and in the second options there is a change of optimum solution corresponding to change situation, that too with respect to objective functions and with respect to constraints. So, this is actually a very useful as per the business environment is concerned, because most of the business are very dynamic, highly volatile and highly uncertain, and there is huge risks, and obviously there is lots of external factors, and there is lots of competitions, and sometimes the particular structure you will change, where there is a increase of competition levels, and there is a high chance there is a decrease of competition level. So, that means there anything can happen in future. So, if you are in a position to predict the future kind of structure, the business structure, then you allow that change to the optimal solution and look for the again the change optimal solutions. So, that means the typical structure is that if you are in a position to predict the future kind of problem structure or the problems the kind of business structure, then again you may be in a you must be in a position to look for the optimum solution with the changing situations. So, ultimately the challenge is how best you can bring the possible changes as per the future requirement, that too with respect to objective function, with respect to constraints and the kind of condition. And so, that is how it is more interesting, and we must before you start this problem and bringing the kind of change, you must have enough exposures, enough understanding about the business problem, enough knowledge about or the idea about the business environment altogether. Then you can actually bring the possible change, and then look for the a possible optimum solution corresponding to particular change. And finally, so what I have already mentioned. So, either the optimal solution will change, or optimal solution will not change. In fact, sometimes if optimal solution will change, so the value of the objective function will change, and the number of decision variables will remain constant. Only the values of the decision variable will change. As a result, the z value will change, that the objective function value will change, and sometimes the change there will be structural change of the optimal solutions. Initially, there may be typical clusters, let us say with respect to 4 variables in the optimal solution, original optimal solutions, it is only 2 variables are there. Now, with respect to change, then you will find all the values of the decision variables are in the track to address the problems and to come with a kind of solution, which is not economically feasible and in fact socially sustainable or environmentally sustainable. So, that means, so what we have addressed till now, it is the kind of linear programming structure through which actually we are addressing the problem corresponding to the business objective, business constraints and the business conditions, and looking for the optimum solution, and again looking for further optimal solutions corresponding to the changing environment, that to business dynamics with respect to objective function, constraints and conditions. And then we can actually, that means technically we have actually enough understanding or enough flexibility to address the problem more effectively, and then come with a kind of management decisions as per the particular business requirement. With this, we will stop here. Thank you very much. Have a nice day.